how do we dilate a shape on a graph? So here's our first example. We have 3 points here. These are going to connect up to make a triangle because a triangle is 3 points. And we need to dilate it by a factor of 2. This is called our scale factor. So basically what dilation is we need to make a graph bigger or smaller. We're just changing the size basically. So for example, if we had a shape like this, and we dilated it by a factor of 2, that means we're making it 2 times bigger. So it's going to become like this. It's going to become like twice as big. So first we're going to start by graphing our original triangle. So we need to plot each of these 3 points. Let's start with point A, which is 1, 2. So x is 1 and y is 2. So when x is 1, x is left and right, and positive numbers are to the right. So x of 1 means we need to move 1 square to the right. And then y is 2. Y is up and down, and positive numbers go up. So we need to go 2 squares upward. And this is going to be where point A is located. We'll go ahead and label it point A. For point B, x is 3, so we need to go 3 squares to the right. And y is 2, so we need to go 2 squares up. And this will be point B. And finally, C is 2, 0. So x is 2, that's 2 squares to the right, and y is 0, so we actually don't have to move up or down at all. So this is going to be point C. And once we have our 3 points, we can then connect them up with lines like this. So now we need to draw our dilated version, which has a factor of 2. So everything is going to get multiplied by 2. And we do this individually for each point and for the x and y of each point. So let's talk about point A first. Point A is 1, 2. 1 for x, 2 for y. So to dilate it by a factor of 2, we need to multiply each of those numbers by 2. So 1 times 2 is 2, and 2 times 2 is 4. So our new point for A is going to be 2, 4. So x is 2, that means we need to move 2 squares to the right, and y is 4, so we need to move 4 squares upward. And this is going to be our new point A. And whenever we're drawing the dilated version of a graph, we label all of the points with a little apostrophe, and we call it prime. So this is A prime. Let's go ahead and figure out what point B prime is now. So B prime, 3, is now going to become 6, because 3 times 2 is 6. And then 2 times 2 is 4, so that's going to be 4. So B prime is 6, 4. So x is 6. That means we need to move 6 squares to the right. That's pretty far. And then y is 4. So we need to move 4 squares upward. And this point right here is going to be B prime. And finally, let's find C prime. So x is 2. 2 times 2 is 4. So it's now going to be x equals 4. But y is 0. And 0 times 2 is still 0. So 4 squares to the right because x is 4. And y is still 0, so we're not going to move it up or down. So this is going to be C prime. And now we just need to connect these up with our lines like before. So there you go. This is our new dilated version. It's twice as big. But you might be noticing something strange. I thought that dilation was just supposed to make it bigger. But as you can see, we also moved the shape over to the right. While dilation doesn't actually just make it bigger, it makes it bigger with reference to the center of the graph here. So instead of just a flat triangle here, I want you to imagine this triangle is being like shot out from the middle of the graph. So here's the middle of the graph, and the triangle is like coming out of the middle of the graph. So a dilation is basically making it twice as big, but it's doing it by shooting it out twice as far from the middle of the graph. I think this would be easier to see with like a square. So like I want you to imagine a square, and then if it was coming out from the middle of the graph, it would look something like this. Basically, it's just coming out at you from the middle of the graph. So here's another example of a dilation, but this time we're doing it by a scale factor of 1/3. So whenever you do it by a number bigger than 1, then you're making the graph bigger. You're extending it out farther as well. But whenever you're doing it by a fraction that's less than 1, we're actually going to be shrinking the graph and bringing it back in closer to the origin, to the middle of the graph. So let's go ahead and plot our original graph. I'll show you how to do that for point A, and then the rest you can do on your own if you want. So point A, x is -3 and y is +3. So x is left and right, and negative numbers go to the left. So we're going to move left 3 squares. And then y is 3, y is up and down, and positive numbers go up. So we need to move 3 squares upward. and this is going to be point A. So I'm going to go ahead and plot the other points now and connect them up with the line. So I've connected these up with the line, and as you can see, this triangle is pretty big. But we need to shrink this triangle now by a factor of 1/3. So remember that multiplying by 1/3 is basically the same as dividing by 3. So let's go ahead and do point A first. Remember that it's now going to be A prime. And -3 divided by 3 is -1. 3 divided by 3 is 1. And then 1 negative sign, so the negative sign stays. And then 3 divided by 3 is 1, positive 1. So let's go ahead and plot this point. -1 for x, that means we need to move to the left because negative numbers go to the left. So to the left 1 square. And then +1 for y, so we need to move 1 square upward. And this is going to be A prime. And just as a sanity check, yes, this makes sense. A is still in the top left of the graph, but we've now shrunk it down closer to the middle. Next is B prime, and we're going to go ahead and divide each of these by 3. So 1 divided by 3, that's a fraction that you can't simplify. So it's going to stay as 1/3. And then 4/3, you actually can't simplify either. So it's going to stay as 4 divided by 3, 4/3. So let's go ahead and plot this. We have 1/3 for x. It's a positive number, so we're going to the right, but we're only going a third of a box to the right. So it's only going to go like this far. And then we need to go 4/3 boxes upward. So if we think of this as like pieces of a pie, 3/3 is an entire pie, right? But then we also have a 4th third, which is like this much. So we're moving an entire square upward plus another third upward. And this is going to be point B prime right here. And finally, let's go ahead and plot C prime. So -2 divided by 3, you can't simplify that. So it's going to stay as -2/3. And then -3 divided by 3, we can simplify that because 3 divided by 3 is 1. And we have 1 negative sign, so the negative sign is going to stay. So let's go ahead and plot this. We have -2/3 for x. X is left and right, and negative numbers go to the left. So we need to move 2/3 of a box to the left. That's going to be like most of a box, but not quite the whole thing. And then -1 for y. So y is up and down, and negative numbers go down. So we need to move 1 square downward. And our point C prime is going to be about right here. So let's go ahead and connect these up with lines. So there you go. We've dilated this triangle. And not only is it smaller, we basically divided the size of it by 3, but it's also now closer into the middle of the graph. So now you know how to perform a dilation on a graph. But chances are that if you're needing to dilate graphs, then you're also probably going to have to do the other types of transformations, which are translations, reflections, and rotations. So if you want to learn how to do those, then you can watch this video right here. And as always, if you have any questions about this video, go ahead and leave it in the comments, and I'll be sure to answer your question. Thanks for watching.